Hello everyone. This is another example of dependent source circuit for the maximum power transfer to the load R. Here we will analyze this network for maximum power transfer. The condition of maximum power transfer is the load resistance must be equal to Thevenin's equivalent resistance. In a dependent source circuit, RTH can be calculated by two methods. Method 2 is discussed in the previous example where we can see this RTH is defined as open circuit voltage divided by short circuit current. Here in this example we used our method 1. For method 1 we will replace all the independent sources by their internal resistances and connect a 1 ampere current source and assume the voltage across its terminal is V. Here we can connect a voltage source and assume it's provide a 1 ampere current. So in this example we use this 1 ampere current source and calculate the resistance. If you analyze this resistance at AB terminal, that will be the voltage of this terminal, that is V, divided by current flowing through the terminal, that is 1 ampere. So our RTH is V divided by 1. Now calculate this voltage V by using nodal analysis. For the nodal analysis, we will assume one node as a reference node and other node voltages. Let's see. Here we assume this is our reference node and this node voltage is V1 and this node voltage is V2. If you analyze the network, this V1 is equal to Vx, and if you analyze this V2 also connected to 10 ohm resistance through a 0 volt potential, and the voltage across this 10 ohm resistor is V. So we can say this V2 is equals to V. So here we can say this V1 is Vx and this V2 is V. Now assume the branch currents. Here we can assume this current is I1. This current assume according to the polarity. This is I2 and this current is already given, and 2 ohm resistance current is I3, and this 10 ohm resistor you can say according to the polarity, this is I4 and this is 1 ampere current. So apply KCL on both nodes. Apply KCL at node 1. Our KCL equation at node 1 is I1 is equals to I2 plus I3. Here you can say this I1 is 0 minus Vx divided by 3, and this I2 is Vx minus 0 divided by 6, and I3 is Vx minus V divided by 2. Put all the values in the KCL equation. After solving these equation, we get 6x minus 3v is equals to 0. Now apply KCL at node 2. Our KCL equation at node 2 is I3 plus 0.5 Vx plus 1 ampere is equals to I4. That is incoming current is equals to outgoing current. Now see the values. I3 is defined as Vx minus V divided by 2, and let's see the value of I4. I4 is V minus 0 divided by 10. So put all these values. After solving these equation, we get 10Vx minus 6V is equals to minus 10. Solve the equation 1 and equation 2 and get the values of V and Vx. After solving the equation 1 and 2, we get Vx is equals to 5 volt and V is equals to 10 volt. Now calculate the value of RTH. RTH is V by 1. So here we get our RTH is 10 by 1, that is 10 ohm. This is the concept of calculating RTH for a dependent source circuit, and by this method we can easily calculate our RTH. Now see the values of the maximum power transfer to the R. For maximum power transfer, this R must be is equals to RTH, that is 10 ohm. Thank you for watching the concept. Please like and subscribe my channel.